Today we'll talk about similarity proofs. Our objective is that we will be able to use similarity theorems to prove triangles are similar. So before we do the proofs, let's recall some things that we've learned in previous lessons that we're going to need for today's lesson. There's 3 ways to prove that triangles are similar: by angle-angle, side-side-side, or side-angle-side. In angle-angle similarity, we have 2 pairs of congruent angles. So it could be A and D with B and E. It could be A and D with C and F. It could be B and E with C and F. Doesn't matter which 2 pairs as long as there's 2 pairs. Side-side-side similarity means that all the ratios of sides simplify to the same number. So AB over DE would have to be the same as BC over EF, which will be the same as AC over DF. For side angle side similarity, we need to use sides that border around the same angle. So let's say if we know angle A and angle D are congruent, then we would need to know that AB over DE is the same as AC over DF. So see how A is in both of these segments and A was one of the angles. D is in both of these segments and D was one of the angles. Some things from previous units that we're going to need today are vertical angles. So that'll be when 2 lines cross. Those are the angles right across from each other and they're congruent. Alternate interior angles, that's when we have 2 parallel lines with a transversal. The alternate interior angles are congruent. And corresponding angles are when 2 lines are parallel. And then if they're in the same position, they're congruent. Reflexive angles, you heard reflexive when we did congruent triangles when they shared a side. Reflexive angles would be like if we had 2 triangles laying on top of each other, like this. Let's see if the big triangle is A, B, C, and the little triangle is D, B, F. Because they both share angle B, like if I drew them separately, D, B, F, and A, B, C, since they both share angle B has to be congruent to angle B, and that's reflexive. So just like in congruent triangles, if they shared a side, it was the reflexive property. If they share an angle, it can also be the reflexive property. So let's look at some proofs. Oh, recall that the S in side angle side and side 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 means the sides are proportional. Which means the ratio must be the same between the corresponding pairs of sides. So just like with our congruent triangles proofs, we're always going to start with the given statement. So OT over ML equals PO over MN equals PT over LN. And we know this to be true because it's the given statement. Since these are all equal to each other, that means they're proportional. So therefore, we know that it's side, side, side similarity because we have 3 sets of sides being proportional. So we can say triangle TOP is similar to triangle LMN. Again, let's start with our given. AS over AC equals AR over AZ because that was given. So we know we have two pairs of proportional sides. So we either need to prove that ZC and RS are proportional to the other sides, or we need angles that connect this. So if we have AZ and AR, AC and AS, those all touch this angle A here, and those are vertical angles. So we know that angle ZAC is congruent to angle RAS because vertical angles are congruent. Because we know those two things now, we can prove the triangle is similar by side angle side similarity. So triangle CAZ is similar to triangle SAR. All right, and our final example. Again, our given statement goes first. So we know that BD is parallel to BC. Well, since these triangles overlap and I know they share angle A, I know that angle BAD is congruent to angle CAE because of the reflexive property. Then, because these are parallel, I can use corresponding angles for angle B and angle C. So angle ABD is congruent to angle ACE because corresponding angles are congruent. So I've got two pairs of angles, so angle similarity is how I know that triangle ABD is similar to triangle ACE. That's all for today. Fill in your summary and I'll see you in class.